Hi friends, today let us start about moment of inertia. See, we had learned in Newton's laws of motion what is inertia. Inertia is a property of a body which opposes the any change. If body is at rest, it will try to remain at rest. If body is in motion, it will try to remain in motion unless and until any external force is applied on it. This is about inertia in linear motion or translatory motion. In the same way, we are going to learn about moment of inertia, or the other name for it is rotational inertia, that is in case of rotational motion. See, we very important one sentence we had learned: mass is a measure of inertia of a body in linear motion. So what does this sentence mean? It means if the body has more mass, then the inertia is more. Means you need a larger force to change its state of motion. Now, similarly, in case of rotational motion, the body cannot be rotating on its own. You need some torque to rotate it, right? You need something. A body cannot rotate about its axis on its own. So, what is required? That is the inertia, and this inertia is named as moment of inertia or rotational inertia. So, what is the role played by mass in translatory motion or linear motion? Same role is played by moment of inertia in rotational motion. So always remember, say you had learned linear displacement s, angular displacement theta, linear velocity v, angular velocity omega, linear acceleration a, angular acceleration alpha, force F in rotational torque. So, what mass is playing the role in linear motion? That role is played by moment of inertia in rotational motion, and it is denoted by capital I. I repeat, moment of inertia play the same role as that of mass in linear motion. So please focus on this diagram. In this diagram, we can see that it is in 3 dimension any object which is performing the rotational motion. Okay, so here, as per the diagram, you can see this the particle of mass m1, position vector r1. What are these distances? Are they position vector exactly? It is the perpendicular distance from the axis of rotation. And this v1, see, remember first day only I explained you that the particles of the body perform circular motion, and the linear velocity is obtained by drawing a tangent. Same way, second particle mass m2, distance perpendicular distance from the axis of rotation r2, tangent along this is a circular path, along that it is velocity v2. Same way in case of third particle. So all these particles may have different linear velocities, but the body as a whole is having one common angular velocity, right? So how do I define moment of inertia? The moment of inertia is defined as m1 r1 square plus m2 r2 square up to mn rn square. That is, I is equal to sigma mi ri square. Now you understand how I write it. This is a mathematical form. Moment of inertia is sigma I is equal to 1 to n mi ri square. Okay, and these are the circular path and these are the velocities v1, v2, v3. These particles performing circular motion. R1, R2, R3 perpendicular distances from the axis of rotation. So moment of inertia is defined as, बच्चे, moment of inertia of a rigid body is defined as sum of product of masses of particle and square of their perpendicular distances from the axis of rotation. Why I am writing sum of product? Because it is the sum product of what two things? Mass and r square, that is square of perpendicular distance from the axis of rotation. So what is the SI unit of it and dimensional formula? Remember, mass is a scalar for quantity, moment of inertia is also a scalar quantity. Its SI unit is mass in kg r square, it is distance in meter square. So it is kg meter square and dimensional formula ml to t0. Now see, why we have to study this moment of inertia. So I already told you that the role played by mass in linear motion, it is same as that of moment of inertia in rotational motion. It means if greater the mass, greater the force, greater the moment of inertia, greater the torque. You know it, torque is required. There should be some resultant torque if the body is rotating. If with no resultant torque, then the body is in rotational equilibrium. And if it has a greater inertia, it means you need a greater torque to change the state of rotation. Am I clear? On which factor the moment of inertia depends? So moment of inertia depends on mainly four factors. As we know, the formula is sigma I is equal to 1 to n mi ri square. So m is the mass of the body. Then it depends on shape and size of the body. See, because mass may not be distributed evenly for each body. So that is why the shape and size of the body will determine the moment of inertia. Third, distribution of mass about axis of rotation. How masses are distributed about the axis of rotation. And last, position and orientation of axis of rotation, about which axis the body is rotating. See, if you have a ring or a bangle, it can rotate about the center of it, it can rotate about any tangent, it can rotate. That tangent can be perpendicular to the plane of the ring, it can be parallel to the plane of ring. We'll see that later on in detail. So moment of inertia basically depends on these four factors, that is mass, then the shape and size of the body, then distribution of mass, and lastly axis of rotation. I hope it is clear.